5.2.2 over here on the left. First question they ask is, can normality be assumed? So we want to make a histogram to get a rough sketch of whether this is normally distributed or not. So I click the column name to select all the data. Insert chart on Google Sheets. If you're in Excel, it's insert, and then there's a button that looks like a histogram. It's a little icon. It's a manually selected histogram, but if you need to choose histogram, choose that drop down. There's our histogram. Let's see if I can zoom this out. Oh, I'm too zoomed in. That looks roughly like a bell-shaped curve. Okay, it's never going to be perfect. So if it was my opinion, which is it's never perfect with statistics. My opinion is that yes, it can be assumed to be normally distributed. They ask for a mean, so we know how to type. We know how to do that. Equals average, whether in Excel or Google Sheets, either one. So we start at A1. I'm going to click and hold Shift to select all those. So there's our mean, 2.75. Now they're asking for a t-value. T-value depends on your hypothesis statement. So if you read through this, they're saying there's a GPA. They've got 50 random people, 50 data points, I should say. Mean of 2.75. Higher than the preferred mean of 2.75. Well, we got 2.75 for a sample mean. I don't know if that's a weird coincidence or if that's what they want from this problem, but our sample mean is 2.75. So when you calculate your t-value, it's your sample mean subtracted by the population mean, which is mu, divided by the standard error, which is the standard deviation of the mean. That's where you take the standard deviation and divide by the square root of the sample size. But none of that's going to matter here because our x bar, our sample mean, is 2.75, and we're comparing it to a population mean of 2.75. So it doesn't matter what the standard error is, because 2.75 subtracted by 2.75 is 0. 0 divided by anything is going to give us 0 for t. This is a weird question. I feel like I missed something. Maybe not. Okay, so a p-value for that. Remember, when you have z equals 0 or t equals 0, that means it's perfectly in the center. So if you were to draw like a roughly normal distribution and put t equals 0, it'd be right in the center. A p-value is the amount of area that's in the direction of your hypothesis statement. So it believes that the mean GPA for a given course are higher. So it's a right-tailed test. 50% of the data, 0.50, is to the right of that t-value because it's right in the center. So that t-value is, the p-value is greater than 0.05. Then the null hypothesis is rejected. If the p-value is low, we reject HO. So the converse of that statement is true. If the p-value is not low, then we don't reject. HO. I chose the wrong one. Well, fails to reject HO. We have a high p-value. That means we can't reject the null hypothesis. It's very possible, and in fact, our data set supports the idea of a mean of 2.75 because that's what we got from our sample. So the null hypothesis fails to be rejected. There is insufficient evidence to say that the mean is greater than 2.75. We got a mean that was exactly 2.75. Oh, okay. So here, this is a good learning experience for everyone watching. When I did Google Sheets, it gave me an average truncated to 2 decimal places. So that messed up all my other numbers a little bit. We put in 2.75, but look, if you click this and then click this button in Google Sheets to extend the decimal places, it wasn't exactly 2.75. This is what I got for a mean. Something a little bit different. And even though it marked it right, it probably shouldn't have because that made me think I was on the right track. X bar was slightly different. Our population mean was 2.75 that we were comparing it to, the one they said right here. And now that means we got to go actually calculate the standard error. I thought I could get by without doing it. The standard error is the standard deviation. So we need that. So type equals stdev.s, open a parentheses, and then click and drag your data column. My computer lets me. Here, it won't let me, so I'm going to do A1 colon A50 because A50 was the last data point. So there's our standard deviation. The standard error, I'm going to let the computer calculate it. So I'm going to tell equals to tell my computer to do some calculations. It's going to be my value in D9, so that's standard deviation, divided by the square root of my sample size, square root of 50. So there's our standard error. And that's what we need to help us finish calculating. Let me copy and paste it. That's what we need to help us finish calculating our t-value. 2.752460. So it's a little different from 0. Not much, but enough to get our answer marked wrong. 2.752460 subtract by 2.75 and divide by 0.026644184. So that's our t-value. It's a little bit different, 0.09, which is what they got here. And so that p-value, I mean, now that we have the correct t-value, I'll show you how to use the calculator to get a p-value. It depends if it's left-tailed or if it's right-tailed. Okay, so if you need a p-value, if it's right-tailed, type equals t.dist.rt. Then open parentheses, and I think you just need to type in the t-value, 0.092328, then a comma, and then the degrees. It's either this, oh man, I should know. I don't know off the top of my head. It's either degrees of freedom or it's the sample size that goes here. So let me hit enter. Let me just do a quick Google search. T.dist.rt parameters. Those parameters means like the numbers you're plugging into a function in this context. So the parameters are degrees of freedom. Okay, so what I typed in was what they're looking for. Type 49 in for degrees of freedom. So that is our right-tailed probability. That's the area on the right tail from this t distribution. So that's the p-value. Okay, if it was a left-tailed test, then I think it's equals, like if they wanted to test to see if it was less than something, equals t.dist. Oh, no dot. If it's left-tailed, you don't need a dot. You just open your parentheses and type in your t-value and your degrees of freedom. And then two-tailed, that would be if you're testing to see if it's different. That's what would go there. So I think they're going to make me redo everything. Let's see if they just, I think they might have changed the numbers I'm working with. So I'm going to just see if I have the same ones, so I can just get to the next question. P-value is greater than the significance level. Null hypothesis, we fail to reject because we have a large p-value. There's insufficient evidence. Yeah, okay, I got to redo it. So here, I'll pause the video just so I can get to the next part. When I redid it, they were saying like sheet 7, like on this one it's saying sheet 6, so just make sure to switch to whatever sheet that they're talking about. The data is similar, but a little bit different, so you'll want to repeat my steps. Just watch for whichever sheet they're looking for. I might have even missed on the first one. I might have just assumed they were talking about sheet 1, but what are we doing here? Sheet, oops, I don't know what I did. Okay, so they wanted me to use sheet 4. LED light bulb, lifetime 100. Okay, so it sounds like 11,000 is the hypothesized value, and they're trying to determine if the lifetime is less than 11,000. So this is a left-tailed test, so we'll want to use t.dist, not t.dist.rt. Looks like the same type of thing. We need to check to see if it's normal. So let's click this, insert chart. And there's our histogram. I'd say that's approximately normal. Looks like it's got a slight left skew. I don't think that's one of the options. So if I have to choose whether it's normal or not, I'd say yes. I need a mean, so type equals average. A1 to, there's 45. So yeah, stop something. So A1 to A45. I need a standard deviation. It's a sample standard deviation. Now I've got everything I need for my t-value. It's a sample mean. subtracted by the hypothesized mean. I typed that in wrong. Divided by the standard error. I guess I need one last thing, right? I usually type it in programmatically, but for students, this was mean, standard dev, standard error. The standard error is equal to C3 divided by the square root of 45, right? Because the standard error is the standard deviation divided by the square root of the sample size. And so now to calculate t, I'm going to calculate the sample mean, 10881 point, let's just increase those decimals, 10881.234 subtracted by the hypothesized mean. They hypothesize it's 11,000 divided by 162.61283. So with my calculator, I got a negative z-score, which is good. That, I mean, if we're rooting for the alternative hypothesis, that's a good sign. So I need equals t dot dist. That's the left-tailed test. The t value goes in there in the first argument, and then the degrees of freedom goes in the second one. So we have a sample size of 45. That means it's different than the other one we had. Just use true, and that's the part I messed up. I didn't realize there was a third argument there. I put false originally. So that's why the p-value should be 0.2345 instead. Okay. So the other choices I made here, since the p-value, the correct p-value is 0.23 if you use true like you're supposed to. I used false, so that's why I've got the wrong number here. But the p-value is greater than the state alpha of 0.05, so we fail to reject the null hypothesis. If it's less than alpha, we've got significant evidence, and we can reject the null hypothesis. There's something going on here if we have a low p-value. It's a big p-value, though, so there's insufficient evidence. Let's see. I think, yeah, the third one is the same type of thing. I don't think there'll be any new tricks there. I'll go through it quickly after this video, but you'll just want to repeat the process that we did on 1 and 2 here. On part 3, we're going to be using a different t-value calculator because this one is just testing to see if the pole height is a mean of 40 feet. So let's just say you got a t-value. You calculated the t-value like you normally did. Let's say you got that for a t-value, okay? Since it's a two-tailed hypothesis test, you're just testing to see if it's different, not to see if it's less than or greater than. Since it's a two-tailed hypothesis test, you want to type equals t.dist.2t. Type your t-value in just like you did before, and then type the degrees of freedom. I think that's everything. And so that would be my p-value if that was my t-value, okay? Everything else should be the same, though. If the p-value is low, you reject the null hypothesis. There is significant evidence. If the p-value is high, fail to reject the null hypothesis. There's not significant evidence.